Hello everyone and welcome. In today's video, I make some progress on the Skyline project by painting the body and installing the motor and drivetrain onto the chassis. I also get the Jeep ready for spring by doing a bit of maintenance and installing some accessories. And I show the design process of this jack stand in Fusion 360. So I've been able to make quite a bit of progress on the 3D printed Skyline project. After the post-print finishing and priming I did previously, I was ready to paint the body. Before doing so, I filled a small imperfection on the hood with a bit of putty, and I did a little bit of sanding on a few spots where larger imperfections were visible. After that, I used a bit of super glue in a few spots around where the lower trim pieces had separated from the rest of the body. With this done, I was ready to paint. I used some inexpensive Valspar spray paint designed for plastic on this body. For a color, I chose matte white. I figured a matte paint job would look a little better on this car rather than a shiny or glossy finish because of the slightly uneven 3D printed surface. I layered on quite a few coats in order to achieve as smooth of a surface finish as possible. It was looking good so far, although I was losing some finer details. It's looking less like the body was 3D printed, and I like the matte finish. Before moving any further, I wanted to wet sand the paint with some fine grit sandpaper to remove a bit of orange peel that was visible. I applied some more lighter coats, trying to get the surface finish as close to perfect as possible. There's still a tad bit of orange peel, but at this point the paint was starting to get quite thick, and I didn't want to continue adding more coats. I'm pretty satisfied with how it looks right now, although I still might do a bit of sanding with some fine grit sandpaper and apply a flat clear coat. I am definitely going to paint some details, such as the taillights and weather stripping around the windows. Additionally, I might add some decals or a livery to the car, but I haven't decided yet. Moving on to the chassis, I've been able to make a little bit of progress on it. I'm still waiting for a few parts to arrive in the mail, but I was able to get the motor mounted and install the drive shaft. I'm using a brushless Turnigy 11,000 kV motor to power the Skyline. To mount the motor, I simply threaded two 1.6mm machine screws into the front. These particular screws I had on hand were a bit too long, so I grinded them down a bit so that they didn't stick out. These are the gears I'll be using on this chassis. The pinion gear for the motor simply press fits onto the shaft. For the drive shaft, I'm using a 2mm steel rod, which I needed to measure and cut to the correct length. With the drive shaft the correct length, I mounted the motor to the chassis. I noticed that the shaft-mounted drive gear was colliding with the motor mount, so I trimmed off a little bit of material so that it would fit closer to the rear of the chassis. With that taken care of, I installed the drive shaft, making sure everything rotated smoothly. I wanted to spend a little bit of time working on this Jeep Cherokee crawler I built a while back, and I've made several videos featuring this vehicle previously. I put quite a few miles on it over this past summer, and I haven't yet had an opportunity to do any maintenance or install some of the accessories I designed for this body a while back. I wanted to start by having a look at the servo, which had become quite loud and crunchy sounding while steering towards the end of this past season. I decided to open up the servo and make sure everything looked good inside and that the gears were properly lubricated. I began by removing the steering servo from the axle and disconnecting the steering linkage. I then removed the 4 screws from the back of the servo and disassembled it. Everything looked okay on the inside, but I figured since I had it opened, I'd wipe off all the old grease and apply fresh grease. I'm not really sure what the best lubricant to use on metal servo gears is. I just used some white lithium grease. After that, I reassembled the servo, making sure that the seals around each section of the housing was in place, and then I reinstalled the screws. A few of the bolts that mount the servo to the axle had come a little loose, so ideally I'd want to use a little bit of Loctite to keep them secure. However, I didn't have any on hand at the time. After making sure the servo is working correctly, I remounted the linkage. Next, I wanted to remove the differential housing cover and ensure that there was enough grease inside and to make sure that it's clean. As you can see, there's plenty of grease, and it doesn't look like any dirt or water has gotten inside. Next, I wanted to check around the chassis for any cracked or broken parts, or anything that's loose, such as this upper shock mount. With everything on the chassis looking good, I next removed all the wheels and checked to make sure that the wheel weights were solidly in place. A few wheel weights fell off while driving, so I wanted to re-glue them using some shoe goo and make sure none of the other weights were loose. Ideally, I'd like these weights to be around the outer edge of the wheel inside the tire. However, as I mentioned in a previous video, the tires are solidly glued to the wheels, so I just placed the wheel weights on the inside of the wheel, which doesn't look the best, but it works until I decide to get some new wheels and tires. While waiting for the glue to dry, I redrew some sections of the body lines that wore off. With everything looking good mechanically, I moved on to working on some of the accessories. I originally designed and showed these accessories in a previous video. I printed a roof rack, some trim pieces, and some side view mirrors, which is what I'll be adding today. I really dialed in the settings on my printer before making these parts, and chose a slow speed and short layer height to ensure that these parts would turn out well. These parts turned out great, and won't require much post-print finishing. I split the roof rack into 2 pieces before printing so that each piece had a flat bottom to sit on the print bed. I also used quite a bit of support structure to improve the quality of the finished print, which I removed using some side cutters. I also used a drill and a knife to do a little bit of cleanup and make sure the holes were the correct size. I did a little bit of light sanding on the bottom surfaces of the 2 parts of the roof rack and glued them together using super glue. After that, I did a little bit of sanding before applying several coats of primer. After just a few coats of primer, the surface was already looking quite smooth and ready for paint. I just did a little bit of trimming in a few spots where there were some minor imperfections and re-drilled some holes. The side trim pieces turned out very well. All I did was apply a few light coats of flat black paint. To secure the trim pieces to the body, I used a little bit of shoe goo. Although the fitment isn't perfect and they stick out just a tad bit more than what I would have liked, I'm very pleased with how they look on the body. I think it definitely adds a bit to the overall appearance and helps add another layer to an otherwise relatively basic polycarbonate body. The side view mirrors had already been painted black, so all I needed to do was add a little bit of chrome silver paint to make the mirror. After a few coats of satin black paint, I was ready to assemble the roof rack. The first thing I did was glue some magnets to the bottom of the mounts. I'm hoping that these magnets will be strong enough to secure the roof rack to the top of the body. The reason I don't want to use glue or screws to secure the roof rack in place is because ideally I'd like to have the roof rack be easily removable so I can place my FPV camera mounts on the roof for when I want to do some first-person driving. After that, I install the front panels onto the roof rack and install the mounts. I think this roof rack looks awesome. It looks even better in person than it does on video because of the black color, but even with the minimal time spent on any post-print finishing, the result looks great and definitely adds to the Jeep's appearance. Finally, I was ready to install the side mirrors, which I secured using shoe glue. Here's a look at the Jeep as it looks right now. I think just these simple accessories really take the truck to the next level. There are still quite a few things I'd like to add to the body, including adding some windshield wipers and cutting out the molded door handles and replacing them with more scale-looking 3D printed ones. I'm currently in the process of working on my 124 scale shop, which I made a video about a little while back, and I'm in the process of adding a lot of different parts and accessories to it, a lot of which I'm custom designing and 3D printing, including this jack stand. I'm using Autodesk Fusion 360 to design this part, and I'm using the image over on the right as a reference. I started by using T-splines to create the general shape that I wanted. One thing that I'm keeping in mind throughout the entire design process is the fact that this part is going to be a small 124 scale piece, and therefore I need to make sure that I'm making the part strong enough. You'll see throughout the design process, I make things such as the legs and general shape of the jack stand a bit thicker than what you would find on a full scale one. It's a little bit of a mix between making the part look as accurate and realistic as possible, but also making sure that it's thick enough to support a sufficient amount of weight and can easily be printed. I didn't worry too much about making the design a perfect representation of the reference material or anything like that, certainly not as much as if I were replicating a car body that I wanted to look as accurate as possible. My only goal for this part was to make sure that it looked like a jack stand. One thing to note is that this jack stand will not be adjustable like a real one would. I'm modeling this as two separate bodies, which I can adjust up or down within CAD, and use a Boolean command to combine the two bodies and export that model. I'll be printing some jack stands at a low height, and some at a taller height, and maybe a few in the middle. But to print an adjustable jack stand in 1/24 scale that functions just like a real one is just not practical. I tried to make the design process as simple and relatively easy to follow along as possible, but if you have any questions, please feel free to leave a comment down below, and I'll do my best to answer it. Here's a look at the finished jack stand. I haven't yet had an opportunity to print this out yet, although I'm definitely looking forward to it since I know this jack stand is going to be a great addition to the scale shop. As I mentioned earlier, this jack stand won't be height adjustable like a real one. However, I want to design a jack stand like this, which will use a small 1 or 1.5mm dowel pin to set the height. I'll be sure to include the design process in next week's video. Before concluding this video, I want to once again showcase some of the incredible work you guys have been showcasing over on the Make It RC Facebook group. There's so many great vehicles, projects, and builds. What you see here is just the tip of the iceberg. Awesome work, everyone. Seriously, an incredible collection of talent, creativity, and some sick-looking builds. If you'd like to join the group, the link to the Make It RC Facebook page is below in the description. This group is just a casual place for discussion, showcasing your custom RC vehicles, and hopefully getting some ideas and inspiration. And that is all for today's video. Thank you all so much for watching, and I'll see you next time.